Okay, hello everyone. Welcome back. In this lecture, we have to perform this question in which again we have a hexagonal pyramid, and one of the edge length of the hexagonal pyramid is 25 mm, and the axial height is 50 height. Now, in this condition, it is resting on HP on one of its face, and the axis appearing to make 45 with the. So again, while it is resting on HP on one of its edge of the base and the height is 50 mm. So let's start with this question. First, we need a hexagon. So 6 faces, edge method, center point. So this way. Right now we need in this way. Edge length is 25 mm. So this is the initial placement of our hexagonal pyramid. I will tell you why we need this type of placement. Let's start with this one. This is going to be A. This one here is B, C. Okay, just change it to the main drawing. Now, as you see in the previous question, what we have done, we have placed it in such a way that A and D are on the either left or on the right, because we have to freely suspend it from one of its corner. Now, it is given in the question that this hexagonal pyramid is resting on one of its face. So these two corners will lie on the same point here. Let's just complete this one first. This is a base hexagon. Now from the top we will have the slant edges. So just going to connect the slant edges. The center point representing two centers. First one is two centers or 2 points. First one is base center, and the second one is the top point. Base center will be represented, I'm representing with smaller, and the top point is represented by 0. Just going to change these construction line to the main drawing, because these are the slant heights of our this hexagonal pyramid, which are visible in the top view. So they will be in the main drawing. So this is a placement for this thing. Now from here you have to draw the construction lines. These two will be on the same line. These 2 points will be again on the same line, and here. Now we have the axial height, which is 50 mm. Now connect these here. So this, you can see this top point. These are our slant edges which are visible. As you can see, this slant height and this slant height are directly on this edge, this slant edge. This edge is this one, B0, which is directly visible from the front, but this will comes directly behind this one. This 0A is directly behind the 0B, so only one edge is visible. So I'm just going to represent, you can see only one edge is visible, second edge is directly behind this one. So we are making only one thing here, one slant edge here, and we know this A and B are on the same point here. So this point represent A dash, A corner, as well as B corner, because both are on the same vertical line. So this point represent both these points, A dash and B dash corner. Similarly, this one here, we will have in this point, we will have the center point as well as this point F and C. So again, just going to mark this point as 0 dash as well as F dash and C dash. Okay, this single point represent 3 points, 2 corners and 1 center. This one is C dash here. Now this point represent here E and D, because both are on the same vertical line. So this point represent E dash as well as D dash. Now this, why we have used this placement Okay, this top point is 0 dash here. Top is represented by 0, so this will become 0 dash. Now you can see this is our hexagonal pyramid, which is resting on HV on one of its base edge, and this is a central axis. You can see the axial height is here. Oh, this should be 50. Okay, let me make sure whether it is 50 or not. Going to measure it again. This point here and this point here. Okay, so this is 50. Okay, now what should we do is okay, as per the second condition, the pyramid is resting on one of its face, resting on HV on one of its face. So as you can see, this point here represent two corners E and D. So as you can see, this two points are connecting this top point. So when we connect this E, D and 0 dash, E, D and 0, collectively they will make a triangular face. So if I rotate this if I rotate this thing to this direction, to the right of this projection, so this 0 dash, E dash, D dash, this line will become coincident on this one, XY. It means this thing is resting on this triangular face. Similarly, on the left side, you can see this point represent A dash and B dash, both corners. So if we connect this A dash, B dash with 0, it will make a triangular face. So if I rotate this thing to the left side such that this slant edge become coincident with this reference line, so it means it is resting on this face, this AB0. So we have to make sure the hexagonal pyramid resting on one of its face. So just you can follow any of the step. Either you can rotate it on the right or on the left, because both edges represent faces. So just going to copy this thing now. Rotate it either to the right or to the left. In our case, I'm going to rotate in the right direction. So before rotation, just measure the angle between these two lines. First one, this one, and second, this one. 113.4. So I'm going to rotate it by taking this point as a reference and rotate it 113.4 in clockwise direction. So for clockwise direction, we have to provide negative value. This one here. And angle should be 113.4 minus 113.4. So this thing is directly coincident on this reference line. To make sure whether this line is see, visually it can appear that these two lines are not coincident. So to make sure these two are coincident, you can do one thing. Just you can measure the distance between these 2 points, or you can check the angle between these two lines, because they have rotated in a such a way that this line is coincident to this line. Now if and visually it is not looking like coincident, then you can do one thing. Just measure the distance between these two lines. If the distance is 0, it means they are coincident. Or another thing to check whether they are coincident or not is to check the angle between this. Why we are considering only these 2 points? Because we know this point is actually, we have rotated it by taking this as a reference. So this is already coincident. So if this thing is, and by zooming in, you can see it is already coincident on this reference line, or this point is on this reference line, and this thing is looking a little bit upward from this reference line. So that is why, to check the distance, I'm just checking the distance between this point and this line, and which is appearing to be 0. So visually it is not looking like it is coincident, but in actual it is coincident, because the distance between these 2 points, this point and this line, is 0. And another way to check whether it is coincident or not is you can check the angle between these two lines. If the angle is 0, then they are coincident, and if there is any difference in the angle, then you can rotate it by that angle. Just this one and this one. 0.0. So it means we have verified that this line or this face D dash 0 dash E dash, this triangular face is resting on HP or on this reference line. So just do one thing now. Okay, just move this thing to the left side a little bit by some distance. Now we have to trace out the top view from this front view. So first we need this top point 0 dash, which is again on the center. So here we will have 0.0 or top point. Now D dash and E dash are on the same vertical line. So here D is here. So this is our point D, and this from E draw horizontal line again. So this is our point. Now this is D. Now again go for the second one. This point represent A dash and B dash. So draw a vertical line. Now A and B again on this horizontal line. So just going to extend these two lines. So this intersection point will give us A, and here this intersection, this by extending this line, we will get the intersection which is nothing but point P. Now what we need is C and F, which are on this point here. Draw a vertical line from F, draw a horizontal line. This is point F, and from C draw a line again. This is point C. This is our point C, and this here is point F. Now connect these points to make our base hexagon. And connect one of the corner to the top point. Now change these base hexagon and this one of the slant edge to the main drawing. Now you can remove the construction lines to make it a little simpler. So we avoid the confusions. I'm just going to remove these construction lines. Okay. So now you can connect all these points, all this base corner to the top point. See this one here, and from here. Now change all of them to the main drawing. Now you can see this is our when it is resting on this face ED0, which is represented by this line D dash E dash 0. So this pyramid, hexagonal pyramid, is resting on this face. So this is touching the HV. So this is going to become invisible. Okay. Now we need the center line. Center line and this slant edge are on this line here. So again, what we will do to find out the center line from this O dash to a vertical line. Now this represents the center line O. So this intersection point is small o, which is the base of this hexagonal face. Now connect this intersection point with top point. So this is going to become our axis. Okay, just remove these two lines here. Now the next part is to make sure the axis appear to make 45 degree with the VP. So just make a copy of this top view and now rotate it in such a way that this axis become 45 degree with the HP. So just going to rotate it by considering this center point as a reference. I'm going to rotate it with 45 degree angle. So you can see after rotation, this is our figure. Now you can see the angle between this axis and this line is 45 degree. If the rotation is done by minus 45 degree, then this hexagonal face will be on the upward direction and this cone will be on the downward direction. Again, that condition is also true as long as this axis makes an angle of 45 degree with the VP. Now we have to trace out the front view from this top view. So starting with this top point 0, again here 0 dash is on the reference line. So here this point will become 0 dash. Now we need to trace out this hexagonal face. So here again D and E are on the horizontal line. So from E to vertical line, so this intersection point will be E dash, and again from D, this intersection point will be D dash. So these 2 points, this one is D dash and this one is E dash. Now from the center you can see we have C and F as well as this O dash. So draw a line here, C dash, F dash. Okay, this is the extra point. So C and F will lie on this horizontal line or on this line. So from the C, draw a vertical line which will intersect here. So this is our point C dash, and from F, again draw the vertical line which will again intersect the same line here. So this point will become F dash. Now what we need is this A dash and B dash, these two points are on this point, so draw a horizontal line. Now from A, first draw a vertical line. So here this intersection point will give us A dash. Now do the same thing for B. So again this intersection point will give us B dash. Now connect all these corners to make the hexagonal face. This one is A, B, F, and again A. Now connect one of the corner with the top point which is 0 dash. Now change all these lines to the main drawing. So this is our main drawing. Now remove these lines, construction lines or projection lines or projectors. Now connect all the edges, slant edges, this one here. Now need to draw this here because this is this E dash O dash slant edges actually behind the body, so it will be not visible. It is not going to be visible, so not need to connect these two lines. We have already created this D dash 0 dash. Now go with the second one. This one is F dash, and here this one A dash 0 dash. Now change all these slant edges to the main drawing. Now we have to make sure which one is invisible. So you can see this E dash 0 dash slant is actually behind the body, which is already invisible, so I'm not going to make any changes to it. And these two edges along with that one E dash 0 dash, this F dash 0 dash and A dash 0 is A dash and 0 dash, these two slant edges are behind the body, so these two become hidden. Now what we need this central axis. From 0 draw a horizontal line, vertical line, and from this point, again this point of then O dash, so just make this intersect with this vertical line. So this intersection point is 0 dash. Now from this point make it connect this point to the stop point. This is our central axis, and you can remove this now. So this is our projection now, in which you can see this is a hexagonal pyramid in which base edge is of 25 mm and it is resting on HP on one of its face. So the axial height is 50 mm and you can see both corners A and B are on this point, which are represented by this point on the front view. So this point here, or you can say this inclined line, not only represent a slant edge, it will represent a slant face or simple triangular face, which is A, B, 0. Now here, same thing is here. You can see this point represent E and D corner. So in actual, this inclined edge represent, instead of a slant edge, this inclined line represent this triangular face, D, E, 0, this triangular face. You can this one, or you can change it to this one. Just using this thing for the okay, instead of hatch, I'm going to use gradient. So this edge will represent this triangular face or this slant face. So now if I rotate this thing to the right so that this line become incident or coincident with this reference line, it means this face is on the HP or on the reference line. That means, as per the question, this hexagonal pyramid is resting on HP or on the reference on one of its face. So from this condition, we have traced out our top view and make a copy. Then we have to rotate it in a such a way that along with this condition, while resting on the HP, see, while resting on the HP on this triangular face, this axis makes an angle of 45 degree with the VP. So this is our resting face, AD, ED0. So this is our resting face. So while resting on this face, this axis makes 45 degree with the VP. So this is our final front view, which is traced out from this top view. So this is our solution. Okay, thank you.